Good evening.
Good evening, sir.
So what are they teaching now?
Vectors. Motion in a plane chapter.
Projectile motion?
Yeah,
No, projectile
they
motion.
started that.
When did they start?
They started, sir, like yesterday, day before yesterday. Sir.
Okay, so what are the projectile motion from a height they have done? From a height
Yeah.
and from inclined plane,
Yes, they took that too.
then everything is done then. Any difficult questions?
Yes, sir.
So okay, you want
Kind
to
of.
send this? You want to send the snap?
Don't have. I didn't take photos yet.
Okay, fine. Uh, so projectile motion is what? Is a motion of a body thrown from the surface of Earth at an angle, right? So they say this is the Earth's surface. The simplest thing we can consider is through the Earth's surface. Say mass m. I'm throwing at an angle with the initial velocity u, say theta. Okay, so this will go up like this and come down like this.
Yes, sir.
Okay, this projectile motion and this, what is this curve? Is it a special curve or some arbitrary curve? Circle, is it a circle? What type of a curve is it?
Um, projectile.
Uh,
Upward and downward curve. Yeah.
no, parabola.
Oh, okay.
Parabola in x and y. This is a parabola in the xy plane. In the sense y will be x square, x and then constant term. Okay, and yes, and this relation they would have derived it. It's not difficult to derive. So this, but what about this motion? Suppose Earth's surface, I throw this thing vertically up.
Yeah.
Okay, so this will go straight up and then come down. Okay,
Yeah.
is this a projectile motion?
Yeah. Yes, sir.
What are the difference
This
between
is
this and
also.
the? Huh?
This is a projectile motion. The angle it is thrown at only to first.
Yeah, here this is a special type of, or you can say special case where theta is how much here? What is the angle of projection in this second case? This one, right?
Yeah.
90 degrees. So general projectile, which is theta, if you put theta equal to 90, you'll get this vertically projected this thing. This is 1D motion. This is along a line. This one is 2D, the first one. Is that clear?
Yes, sir.
So the 1D motion, if I consider this vertical thing, then it's motion on the y-axis. Okay, so the next complication is instead of throwing a projectile from the Earth's surface, I can throw from a height. This is the Earth's surface. See, there is a building here. So from this top of the building, I can throw this mass up. So it'll go up and come down. So in this case, what is this curve? First case, it was a parabola. Okay. Second case, special type of parabola becomes a straight line. Okay. Here, what is the curve?
It's a parabola.
Yeah. Still a parabola only.
Yeah.
See, the previous parabola is like inverted U, full U. Okay.
Yeah.
In this case, this portion is cut off.
Yeah.
because I'm throwing from height. Still, it's a parabola.
Yes.
Okay. Next higher complication is I throw from a inclined plane. This is the Earth's surface. So there is a slope here, and from this point, I'm throwing up the velocity u, which makes an angle alpha with the surface. But with the Earth, it will make some different angle. It will make the same angle
Yeah.
theta. Okay, with the Earth,
Yes.
with the Earth surface. So here also the path is again a parabola only,
Yes.
because parallel depends on the fact that along the horizontal direction there is no acceleration. In the vertical direction there is acceleration, and acceleration is same as force. And the vertical direction, the force is the gravity force. So there's
Yeah.
still a parabola. So that the inverted U parabola. So you truncate from here and truncate here also. So this is removed and this also removed. Okay. From a height is a truncated parabola where the initial part is truncated. Okay. From an inclined plane, both sides are truncated. Or you can say truncate only one side if you take this as a horizontal level. Okay. So next complication
Sir.
is what? Instead of throwing from the bottom, I can throw from the top also, from a higher place. So instead of throwing from down, I can also throw from some other point at the top at some height. It could be anywhere. Okay. From here I can throw at some angle, may not be horizontal. At some angle.
Won't the angle come in theta? Like you
Sorry.
cos theta, you sin theta for horizontal and vertical motion
Yeah, I'll come to
in
that.
terms of vectors. Yeah.
Yeah, I'll do that. Just first get some idea here. Okay, this also is
Yeah.
a parabola, again a truncated parabola.
Yeah.
So these are the only complications we can have. But everywhere it's parabola, but it can get truncated if it is a not from Earth to Earth. It is from Earth surface to Earth surface, then it's a full parabola, inverted parabola. Okay, inverted
Yes,
U.
sir.
From a height, it become truncated. Even from a inclined plane, it get truncated. So projectile motion, the ball is projected. Okay, so this is ground to ground, full inverted U parabola, ground to ground projection. Okay, so the relation between y and x, it's a parabola, and that x versus y is called trajectory. Trajectory means path of the body. Where is that thing? This one. Y equal to x, some tan theta. Theta is constant for a given projectile, theta is fixed. Okay, it's not a variable. So this x into some constant and then x square into g is constant, u is constant, theta is constant. Okay, so it's
Yeah.
minus x, so that's why it's inverted u. U parabola will be y equal to ax square plus bx plus c, where a is positive. That a is negative, it's inverted u. So here the e is negative, correct?
Yes, sir.
This one, negative sign here. That's an inverted u parabola. This is projected from a height, so it's inverted U parabola, but this initial part is truncated. Okay. Here, this is also from a height, but yeah, it's thrown at an angle with the horizontal. Inclined plane is not there. Oblique projection from a certain height, that's 11. And then, well, really, so there, so NEET portion, this projected along the inclined plane is not there.
It is there.
Okay, here they are not included. Fine. So even in this inclined plane, you can take the horizontal motion as the Earth surface only, and the vertical motion is this one. There you have to find out, again, the maximum height is only that point where Vy becomes 0. But that maximum
Sir,
height and this maximum height from the surface, that will be different.
yeah. Sir, just a minute, sir.
Uh,
I'll be back. Yes.
okay.
Sir, I'm back.
Now, so what I said, this one. See, even this truncated parabola, this point is the maximum height point. Okay, at that maximum height point, say this point. Okay, at the maximum height point, what is the thing? Vy is 0. That is the characteristic of the maximum height point, right? Because beyond that, you're not able to climb up. That means Vy has become 0 at maximum height from the Earth surface. Okay, let me call it H. At this point, the property is the vertical velocity Vy has become 0.
Yeah. Yeah.
Okay, but that point is different from the point where it's at the maximum distance from the inclined plane. The maximum distance from the inclined plane could be different at this point. This could be H prime. Okay,
Yeah.
so that we can find out from where it is. Okay, let me solve some questions.
And sir, I got my marks.
How much did you get?
Got
Which
like
marks?
170.
For
Physics,
exam.
yeah, OT, yeah, OT.
Okay, how much did you score?
Got less a little bit this time.
How much?
Got like 145,
145 out of,
180. Yes.
okay. So what mistake you made?
Partially, I made mistakes. That oblique motion projectile. This
Oh,
thing that we are taking it now. Yeah.
okay. Can you send that snap of that one? Or phone is not there.
I'll try, sir. Yes, sir. Sir, I don't have a question paper right now.
Okay.
Can I send later?
Okay, fine. So tomorrow you get it right. So
Yeah.
today is Tuesday, no?
Yeah.
So this week you can have Wednesday, Thursday. Tomorrow you can have
Wednesday.
class.
Tomorrow we'll
Wednesday.
have class.
Tomorrow what you have?
No, like no, day after tomorrow. I mean,
No, tomorrow you're free.
I have that class tomorrow.
Okay. Thursday,
Yeah, on Thursday I'm free.
Friday.
I have again. Then Saturday I'm free.
Okay, so then you'll have class on Thursday and Saturday.
Yeah.
Okay. Uh, let me then open this one. Just a minute. This is the one. Okay, so with the inclined plane, theta is the horizontal Earth surface. So here you can see a parabola which is getting maximum at this point. Okay, where Vy is 0. But it will be at the maximum distance from the surface, or it could be at a slightly different point. So here you can,
Sir, I sent you now, like
yeah.
that.
So this is different for
Weekly it is 4
27.
only.
Okay, you did send the question paper, fine. Uh, Physics,
Most in a plane complete chapter we have.
okay. So straight in motion is done then, previous test.
Yeah.
See here, uh, what you have to analyze the motion in two directions. Which one? Here they have taken x-axis along the plane and y-axis perpendicular to the plane. Okay, so in this case, there is acceleration x direction, also y direction, because it's vertically downwards v. That v will have a component, that g will have a component along this x, because this is g, right? Okay, so this g is making an alpha with the perpendicular of the plane. Are you able to see it? Just a minute. Uh, G is vertically downwards.
Yeah.
This one, okay. Okay, so alpha is the angle of the plane with the horizontal. So this is, so if the angle between two lines, when use this result, if you have two lines,
Yeah.
with Baba, just a minute. See, this is the horizontal line, and there is one more line like this. The angle between these two is alpha. Then the angle between their perpendicular, say, perpendicular to this horizontal line is vertical. Okay, and this inclined and perpendicular to the plane, you can say it's normal. So the angle between these two is also alpha. This you can use as a standard result. Is that clear? If
Yeah.
the angle between two lines, I'm not see the pen man. If the angle between say two lines is alpha, then the angle between the perpendiculars, if I draw a perpendicular of this first line, okay, and perpendicular of the second line somewhere, anywhere I can draw. Okay, so even the angle between these two perpendiculars is also alpha. Okay, I don't take it as a result. So this alpha is between the horizontal and the plane, and perpendicular to horizontal is vertical.
Yeah.
So this is this vertical line. This vertical line.
Yeah.
Okay, and perpendicular to this plane is the normal, which is this one. So the angle between those two is also alpha. Okay, so G, if I split it into two components, one perpendicular to the plane, normal to the plane, it's AY, and parallel to the plane is Cx. So here in this, with this choice of x and y, acceleration is both in x and y direction. Okay, if I choose my x-axis, this one, say x1, then along x1 there is no acceleration. Only along this vertical y1 there is acceleration. This also got some advantages. This choice also got some advantages. Okay, so with this choice of x and y, there is acceleration both in x and y direction. Okay, and the initial velocity is u, angle theta is with the horizontal, and so the angle with the plane is theta minus alpha. Is that clear?
Yes, sir.
With this choice of angles, with the theta is with the horizontal and alpha is the angle made by the plane with the horizontal. So the remaining angle, theta minus is the angle between the u and the plane. That's why u along the x-axis is u cos theta minus alpha. And uy
Yes.
is u sin theta minus alpha. Is this clear?
Yes.
Okay. And acceleration of x and y is this one, g sin alpha, because g is this one. G cos alpha is vertical. And actually it should be minus g cos alpha. Okay. And ax also negative. Both should be negative. They mean, okay, here they put the negative sign here. Okay, it will be better if I put the negative sign here because it's on minus, and then I have to write the, okay, either way, somewhere sign has to come, negative sign has to come. So, vertical motion, here vertical means y motion. Instead of calling vertical, we call it y motion. Okay, v equal to u plus at, and a is negative because speed is going to decrease along the y direction because force is along the downward direction. And here this ay is positive, which is g cos alpha. And this y motion is equal to ut plus half at square. So basically, you're writing three equations of motion in the y direction. Okay, similarly, three can be written in the x direction.
Kinematic equations.
Yeah, three equations of motion: v equal to u plus at, is equal to ut plus half at square, and then v square to u square plus 2as, both in the y direction and x direction. And both along x and y, it's negative acceleration because acceleration along the minus x axis and acceleration in the y direction is the minus y axis. So both are
Can you
deceleration.
solve the formula again, sir?
Sorry?
Can you solve the formulas again?
No, formula will derive from this, it will come.
Like I'll
Okay.
just note it down. Then we can
Yeah.
derive.
So time of flight. Time of flight. So at this point, Vy has become
Yeah.
okay. This value of Vy t is Vy g cos alpha. At this point, it becomes Vy. So if I know Vy, I can find time. In this thing, if I know Uy is known because this is the initial condition, Ay is known. Okay, so if I know Vy, I can get the time, flight time. Okay, he's saying this uy is same as initial vy is same as uy, but just in the direction is changed. So magnitude wise they are same. Okay, so vy is known then. Vy is same as uy with the minus sign. So vy just have to put minus uy and take this thing here. So it become 2uy by ay. Huh? What he's saying is, see, the initial velocity in the vertical direction is uy, right? When it hits
Yeah.
here, it becomes vy. But he's saying vy is same as uy, but with the direction opposite.
Yeah.
Okay, that I have to understand. Okay, right now let's assume that is true. Okay, so if we do that, just put vy as minus uy. Okay, so minus uy, bring it this side, become 2uy, and take this thing to the left side, it become ay into t. So 2uy by ay is the flight time. Okay, is it clear? And uy you can
Mm.
write as u sine theta minus alpha. Uy is u sine theta minus alpha. Because this angle is theta minus alpha. So sine of this is this one, vertical component. So flight time formula is clear. Ay is g cos alpha. The only thing we are using is when it's hit the plane, the direction of Vy is same as the initial Uy with the opposite sign. And using the first equation of motion in the y direction, Vy equal to Uy plus 80, in that put Vy equal to minus Uy. And T will be capital T, the flight time. Is that clear?
Yes, sir.
So this is the flight time formula. After that, range is x no. You have to find the value of x at t equal to capital T. Range is nothing but x no. At this range is this x at t equal to capital T. So in this formula, x equal to ut plus half at square with the proper signs, put t equal to capital T.
Isn't capital T derived from like 2 u square by 2gh, that
No, no,
formula?
no. You know the time, right, to go from here to the flight time. Once you know
From
the flight time, I have to use s equal to ut plus half at square.
yeah.
Because u is known, t is known, t is capital T. Acceleration is known, t square is known. Okay, the
So
flight time we got from the first formula. Okay, once I know that, I have to use x equal to ut plus half at
yeah,
square. So x is at range at t equal to capital T.
got it.
This one, if you put t equal to capital T, x will become r range. Everything else is known. From that, you'll get this formula range.
Yeah. Yes, sir. I did.
Uh, so time of flight and range is known. This is a different thing. It's again, I mean, this is just normal projectile, but this is just truncated by a plane here,
Yeah.
truncated by a parabola here. Doesn't matter whether it's uh, plane or parabola, but the point where it's hitting it, that's yp. That is the one that matters. At what height I'm truncating it. It's getting truncated at yp. Here also it's getting truncated at yp. Okay, that
Yeah.
yp should be given. It's a property of the hill.
So that it's based on the trajectory in the parabola format.
Yeah, this is a normal trajectory. So we can take x-axis along the Earth's surface and y-axis vertical. Okay, only the truncating point depends on the hill.
Yeah,
Okay, so that hill can be a line or a curve, does not matter. It can also be a irregular shape. But what matters is the height at which it's truncated, which is yp.
yeah.
Okay, to find that yp, maybe we can use it's a line or it's a curve.
Can't you use that v is equal to ut form, v is equal to u plus at formula?
For finding what?
The yp, xp and yp.
No. Explain why means this hill has to be given. What sort of hill is it? Property of the hill should be known. No, here he has given the hill as y equal to mx plus c.
Okay.
Okay, so from that we can find out where it will hit the thing. Similarly,
Yeah.
if it's a parabola means then the equation of this curve should be known. Okay, tomorrow you before the class send me that question paper snap.
Question paper is I'll send yes.
Yeah.
We'll do all the questions.
Okay, after this projectile, they discuss uniform circular motion.
No, they didn't. They only did till projectile motion and all the applications, including time of flight, velocity at last instant, that and all.
No, but motion in a plane, that uniform circular motion is not there.
It's that the complete chapters that given that.
Okay, they are not yet covered.
Yeah.
Uh, any specific question you have? I just checked the NEET syllabus.
No.
Mm. NEET 2025.
Yeah.
Kinematics.
Kinematics we finished.
Projectile motion of the uniform circular motion is there.
Sir, motion in a plane in this.
Yeah. Kinematics is motion, right? Basically, it's 1D and 2D. Straight line motion, which is 1D. Okay, after that, scalar similarity. This is 2D motion. Okay.
They take the motion in a plane, the cover till projectile motion. Uniform circular motion they yet to take. They will take though.
See, this projectile motion is a motion in a plane, no? So, how many lines define a plane? Understand the question?
Three x-axis, y-axis, z-axis.
No. For a plane, just two axes are enough, no?
X and y-axis.
So, for example, this plane of this paper, suppose if they take the horizontal axis x, okay, and the vertical as y, then these two will define a plane. Okay, instead of y, I can also have some other line. Okay, it's actually a line. Let me call it y1. So two lines can define a plane. Need not be at 90 degrees. Like 2 points can define a line.
Yes.
So if you have a point like this, okay, how many lines can pass through this point?
1, 2, infinity.
Infinity. But if you have a second point here, then only one line is possible. Okay, so I can say 2 points define a line.
Two
Okay.
distinct points define like this.
Once I fix 2 points, there is a unique line. I just want to join those 2 points.
Yeah.
Okay. Similarly, if you have two lines, so there is a unique plane.
Oh,
Yeah. Once the two lines are given, then the plane is also given.
okay.
Okay. So for this projectile motion, it's a motion in a plane, no? So what are the two lines that define the plane?
Two lines. Explain no plane.
Yeah. So I can say one line is a mm, Earth Earth surface. Sorry, I can say one line as a obviously the gravity. Gravity will give you a vertical line, right? Gravity gives the vertical line, and there is a second line which is U, the initial velocity. These are the two inputs. So these two lines define a plane.
Yes.
For a given projectile, you can consider input as the initial velocity,
Yeah.
the direction is it's thrown. Okay.
Yeah.
And that gravity is always there. That gives a natural direction. So these two lines or vectors define the plane of the motion of the projectile. Is this clear?
Yes, sir.
Huh. So motion in plane, this only this much is there. Scalars and
Yeah.
vectors, vector addition, subtraction, scalar and vector products. They taught vector product.
Vector product. No.
Okay, right now it's not required. Okay, unit vector, resolution of vector, relative velocity, motion in a plane,
Yeah.
projectile motion, uniform circular motion.
We got any sums in this till what we have learned till now?
Wait.